Hi, welcome back to the lecture series on microeconomics. Now we are in the last part of our discussion on theory of imperfect competition. Today we are going to start our formal discussion on oligopoly. What is oligopoly? Oligopoly means the presence of few sellers in the market. So, it is basically competition among few. So, we can start by giving some example of oligopolistic market competition. Think about the case of telecommunication services in India. So, here we see few players like Airtel, Vodafone, Reliance Jio, Idea, etc. right. So, now we will simply assume that we are dealing with only two competitor firms and see how market equilibrium is going to be achieved. But before we start talking about some classical models of oligopoly, we will start with a general model. Okay. So, we start with the market inverse demand function, right, and that is given as P I equal to D I Q 1 and Q 2, where I is basically 1 and 2. So, this I represents the number of firms in the market, right. So, this is my demand function. Let me give it equation number 1. Then from this inverse demand function, what can be inferred? So, we can assume two results and let me name them result A and result B respectively. So, in result A we can say that the partial derivative of the demand function of ith firm with respect to the jth firm's output is negative, and that holds for both I and j equals 1 and 2, and note that here I is not equal to j. So, what does that mean? That means that if the jth firm increases its output or market supply, then that has a negative impact on the ith firm's price. So, now let us look at the result B, which is basically talking about the slope of the ceteris paribus demand function. So, I hope you remember that we have introduced this term ceteris paribus or ceteris paribus, that means that everything else being the same. So, in this case I can write I equal to 1 to 2. So, that means that if every other things remains the same, there is a negative relationship between firm I's quantity supply and price that it achieves from the market. Okay. Now, we are going to look at a very interesting result from here. So, we know that there is this inverse relationship between price and demand if we are working with a ceteris paribus demand function, but note that here in oligopoly we also talk about strategic interdependence. So, if we look at the last result, which is result B, which talks about the partial derivative of demand function with respect to ith firm's output, and that is negative, the result is not actually that simple as it looks like. Why? Because if the firm decides to produce some units extra or some units less, then its competitor firm may also decide to respond to this output variation, and it may wish to change its output level or market supply level. So, then there will be an indirect impact on the price of the ith firm as well. So, now we are going to break down the change in price due to a change in the quantity supply decision of ith firm into a direct effect and an indirect effect. So, let us take help of the total differentiation and write this equation for farm 1, but you should note that this can also be written for farm 2, right. So, basically we are working with this inverse demand function given by expression 1 for farm 1, right, and we are taking differentiation of that function as if the farm 1 has changed its output level. So, we are going to study what will happen if it happens, if the farm decides to change its output level. So, now let us look at these two components, right. So, this is basically my direct impact which is coming from the ceteris paribus demand function, and this is basically my indirect impact. Okay. So, this indirect impact is basically coming from the strategic interdependence between these two farms. Okay. So, now let us concentrate on this particular term which is basically the crux of the oligopoly theory. So, what does this say? This basically says if the farm 1 decides to change its output level by 1 unit, then by how many units its competitor farm is going to change its output level or market supply. Now, nobody knows the answer to this particular question. So, this is a question for which answer is required, right. So, in essence it is talking about output variation right, and we need to know the answer, but unfortunately there is no clear answer to this question. So, the farm 1 has to guess, right, or conjecture that if it changes its output level, how the competitor farm is going to respond. So, basically there is a conjecture to be made. Okay. So, this is known as the concept of conjectural variation. In oligopoly theory, right, and we will see that for different values or different schemes that the firm assume for this term leads to different types of models. So, now we are going to study the case when a firm assumes the value of the conjectural variation to be 0. So, the derivative dqj dqi takes value 0. So, now let us see what is the implication of that. So, that means that if the ith firm or jth firm changes its output level, there is no response from the competitor. So, this assumption leads to the Cournot model. Proposed by a French mathematical economist Augustin Cournot in mid 19th century. Now, when Cournot assumes this, then what does actually he mean? So, there are two interpretations of this. And both are basically same, but representing them in representing the same concept in different words. So, we will write them down. So, first of all, it can be said that each firm believes that the other firm choice is independent from its own, or it can also be said in other words that each takes the other firm's output, which is basically the market supply, as given, right. Okay. So, now let us formally start discussion on Cournot duopoly model. Okay. So, now we are going to start with the profit function of the ith firm, where I takes two values 1 and 2 because it is a duopoly case. I assume that these two firms has different cost functions. I can assume 0 cost and same cost also, it does not matter, but to have a general model, let me assume that these cost functions are different. So, note that the interdependence in the Cournot model comes from this demand function, right. So, the output decision of ith firm impacts the price that is received by the not only the ith firm, but of the jth firm as well. Okay. So, now that is basically the revenue side. Okay. Okay. So, now let me take out the cost to have the complete profit equation, and I equal to 1 to 2, okay, fine. Okay. So, now we have to derive the first order condition of this ith firm here. So, we know what to do, we have to take partial derivative of the profit expression with respect to the output of the ith firm, and if we do so, we get Pi plus Qi. Now, this is going to be little complicated here because there is strategic interdependence between these two firms. One responds to others output decision. Okay. And of course, we have this. So, this is my first order condition. Now, note that if we are in a Cournot model setup, then basically we assume the conjectural variation, which is this element, plays no role because it takes 0 value, right. So, this entire expression basically disappears, right. So, we can then rewrite our first order condition as right. Okay. So, now do you recognize this first order condition that we have obtained here? Let me call this equation number 2. So, let us study this first order condition element by element. So, first the simplest case. So, this is basically nothing but my marginal cost. So, we get this, then we write equal to. Now, let us look at the other side of the equality, and if you remember our discussions on monopoly, this is basically marginal revenue, right. So, we get back the MR equal to MC condition that basically we have seen in the case of monopoly, or to be general. So, the first order condition what we have derived now basically is the same first order condition that we had in the case of a pure monopoly, right. So, basically the Cournot duopoly model boils down to a pure monopoly model. Now, we are going to analyze the solution of the Cournot duopoly model in terms of a simple graphical and algebraic analysis. Okay. So, now let me write down the first order conditions in detail, assuming that we have the 0 conjectural variation as per Cournot's assumption. So, this is the first order condition for my farm 1 or duopolist 1. Okay. So, now let me name this 3 and 4 equations. Okay. Fine. Now, from 3 what do I get? We get optimal value of farm 1's profit maximization problem. So, that is basically through the optimized value of market supply or output Q1 star, but note that this is a function of the belief of farm 1 about farm 2's output or market supply decision, right. So, now from 4 we get what? As per the normal interpretation of the first order condition, I get the profit maximizing output level of farm 2, but note that this now depends on Q1. So, basically my each of these farms profit maximizing output level becomes a function of the farm's belief about its competitor's choice of output level, right. So, some kind of reaction or interdependence is seen through these two first order conditions, right, and this is known in economics as reaction function. Okay. So, from 3 equation or first order condition we get the reaction function of farm 1, and from the first order condition number 4 or expression number 4 we get the reaction function of farm 2, right. So, as reaction function plays very important role in finding oligopoly equilibrium, let us have a formal definition of that to get our understanding clear. So, reaction function is a mathematical relationship between a firm's profit maximizing output and the quantity of output it believes its competitor firm will produce. Okay. So, now we are going to have a diagram to analyze how to derive reaction function graphically and with the help of intuition. Now, we are going to concentrate on graphical analysis. We are going to have 2 panels of diagrams. We are going to do the analysis only for farm 1, but needless to say that one can very easily follow the same steps to get it done for farm 2 as well. Okay. So, panel A diagram and panel B diagram, we are going to first work with panel A diagram. So, in panel A diagram we are going to measure the marginal revenue and the marginal cost of duopolist 1, and we are going to measure output of the duopolist 1. Now, note that we have already said that the duopolist problem becomes a monopolist problem, and so we are going to find farm 1's equilibrium by equating marginal revenue and marginal cost, right. So, let us first plot the marginal cost curve. Now, we want to make a general diagram. So, here I assume a nonlinear marginal cost curve 1 for farm 1. Now, we are going to draw a series of marginal revenue curves. Now, why series of that we are going to discuss now. So, let us first draw the initial marginal revenue curve, and let me name this MR 1. Now, note that when this marginal revenue curve is derived, the farm 1 assumes a specific value of output level or market supply chosen by its competitor farm 2. So, my marginal revenue is actually a function of the output level chosen by my competitor. Why is this so? Because if you note the demand function, there is strategic interdependence in both the demand functions for these individual duopolists. So, of course, when you derive the marginal revenue from the demand function, then this interdependence will be there embedded in the marginal revenue function itself. Okay. So, if the duopolist behaving like a monopolist assumes that its competitor is going to produce and supply Q2 naught level of output in the market, then it finds its equilibrium at the intersection between this conditional marginal revenue curve and the marginal cost curve, right, and finds the profit maximizing level of output, right, denoted by Q naught 1. So, this is my initial level of equilibrium. So, now let us study how the firm is going to find another equilibrium if it assumes another value of Q2. So, basically if I change the value of Q2, if I change my belief, in other words, then I am going to get another marginal revenue curve. Now, let us study how we can generate this series of marginal revenue curves. So, here I assume a case so let me write that this is assumption, of course, assume okay. So, what does this mean? This means that now I am going to assume that my competitor firm 2 is going to supply less to the market. So, if that happens, then how it is going to impact my price? Okay. So, now we have to look at the result that we have first talked about, right. So, remember we started with some results A and B. So, now if you go back to the result A, then that means actually this, right. So, if the firm 2, my competitor firm, increases its output level, then that has a negative impact on my price, and the reverse side of the story, which actually which is assumed by us, says that if the competitor firm reduces its output level, then basically there is an increase in the market price that is observed by me. So, if I believe that my competitor is going to produce and supply a lower level of output, then I am expecting a higher price in the market. So, basically I am talking about an upward shift of the demand function which I started with. So, if that is the case, similarly marginal revenue will also shift upward in response, because my demand function is now changed, it has gone up, it has moved up. So, the marginal revenue will also move up. So, now let us draw that in our MR equal to MC diagram. So, now let us have another marginal revenue curve corresponding to our output choice Q 1 2, which is less than Q 0 2, right. So, needless to say that again this duopolist 1 will adopt that monopoly type profit maximization exercise in this case and finds another equilibrium, and it will now produce a higher level of output Q 1 1. Okay. So, now this exercise can be repeated for another output level. Let me assume this time a level Q22 which is even less. So, it is less than Q12, right. So, if that happens, then basically we can have another round of shift in demand and the correspondingly my marginal revenue curve shifts also, and these shifts are all towards right side. So, there will be MR3 okay, sorry. Sorry, I made a mistake here, it should be MR1. Okay. So, now let us go back to our diagram. So, we are basically now drawing the third marginal revenue curve in the series, right, and of course, we get another equilibrium and correspondingly we get basically another output level, and the output level produced by my farm 1 has gone further up in response, right. Okay. So, now we have completed our diagram in panel A. Let us move to the diagram which is panel B, and there we are going to plot the relationship that we have seen between the output levels chosen by farm 1 depending upon its assumption of farm 2's output level. So, now I plot Q1 along the horizontal axis and Q2 along the vertical axis, okay, fine. So, now note that I can now plot these points. So, suppose this is a point which talks about whose coordinates are basically Q01 and Q02, right. Okay. So, this is the initial point at which we started, but this is basically conditional upon the assumption of farm 2's output level. So, if the farm 1 assumes that my competitor farm 2 is going to produce and supply at this level, I am going to choose, or my farm 1 is going to choose this much of output level, and then we have seen the repeated reduction in the output level that my farm assumes for its competitor Q12, and then we have seen that in response the farm has produced a higher output level itself. So, Q11, right, and lastly we have chosen another low level of output Q22, and we have seen a higher level of output produced by farm 1 in response. Okay. So, this is what we have seen from panel A diagram, right. So, now if I join these points, then what do I get? The locus of all these points will give me my reaction function for farm 1, right. It can be nonlinear as well. So, I call this R1 R1 prime. So, this is basically farm 1's reaction function. So, these two diagrams in two panels A and B are helpful to find farm 1's reaction function. This graphical exercise can be repeated to find similar reaction function for farm 2 as well. So, we will continue our discussion on oligopoly models in the next lecture.